Greetings! This is a quick little video prepared for the Electronics 2 course at Kansas State University. We're looking at an Arduino board on which is a program that has one A to D input and a D to A output created with those 6 resistors you see on the right, creating a 5-bit word. And the results of the DSP program are shown on the scope screen here. Here's the big setup. Picture of the setup. The scope screen shows the input signal on the top and the output signal on the bottom. This is a very simple DSP low-pass filter implemented, and I'm going to change the frequency, and you can see really the input and output are tracking each other. You notice the steps in the output on the bottom there, the quantization levels. If I spread it out, you can see them a little bit more clearly. That's again because of the only 5-bit D to A converter, but that's good because it shows some of the real issues of A to Ds. You also notice a few spikes or glitches on the output. That's probably caused by timing of the output bits not being perfectly changing at the same time. Anyway, here we are going up in frequency, and everything's fine. There's a simple little one-pole infinite impulse response digital filter implemented in the code, and if I continue going up, now you can see the output decreasing. So ignore the glitches, just look at the output and you can see the output decreasing in size. If I keep on going up, you can see the frequency is increasing, looking at the top. Then it continues to decrease at the output, as it should. And eventually it essentially goes to 0 except for the glitches, which we could get rid of with a suitable analog low-pass filter on the D to A output. But if I continue going up in frequency, something interesting happens. So that's just a little bit of the glitching, but here's the interesting thing coming up. Notice that the input signal here is extremely high frequency relative to where we were, but the output frequency is different. That's aliasing happening. If I continue to go on up, theoretically we should pass through essentially about DC. This is a very low frequency waveform, as you can see. And then if we go up further, then the frequency starts to go higher, but it's not nearly as high as the input signal. Again, that's aliasing.